we're given that r squared equals cosine of 2 theta, so we can determine that r equals the square root of 2 theta. We can determine that dr d theta equals negative sine of 2 theta over the square root of 2 theta using differentiation. Substituting all of our formulas into the formula, we get the surface area equals the integral from negative pi over 4 to pi over 4 of 2 pi times the square root of cosine of 2 theta times cosine of theta times the square root of cosine of 2 theta plus the quantity negative sine of 2 theta over the square root of cosine 2 theta squared d theta. Simplifying the integrand a little bit, we get the integral from negative pi over 4 to pi over 4 of 2 pi times the square root of cosine of 2 theta times cosine of 2 theta times the square root of cosine 2 theta plus sine squared 2 theta over cosine 2 theta d theta. Finding the common denominator inside the square root term gives us cosine squared of 2 theta plus sine squared of 2 theta over cosine of 2 theta. The cosine squared and sine squared is a trig identity, which gives us 1. Rewriting the integral, we can now say the integral is negative pi over 4 to pi over 4 of 2 pi times the square root of cosine 2 theta over the square root of cosine 2 theta times cosine d theta. The square root cosine 2 thetas cancel. We are now left with the integral from negative pi over 4 to pi over 4 of cosine of theta d theta. Taking the antiderivative gives us 2 pi times sine of theta from negative pi over 4 to pi over 4. Substituting in the bounds gives us 2 pi times the quantity square root of 2 over 2 plus square root of 2 over 2. Simplified, that is 2 pi times the square root of 2, which is approximately 8.88. That's approximately 8.886.